All right. Thanks everybody for joining today. My name's Rob Galvin. Today we're going to be going through a new RhoMobile Suite 4.1 feature. Last week, Adam Blum presented the announcement of RhoMobile Suite 4.1 and gave you an overview of what's in the release. So if you didn't catch that presentation, it is up on Launchpad and you can watch the recording. Today we're going to explore just one of those features in greater detail to really get you going in using it so you understand what this feature is about. The feature is intense or cross platform intense, as Adam alluded to it. And we're going to make sure you understand how to use it, show the some of the common use cases, and walk through some code in actually using this API. So today we have a guest speaker, Alexei Tikvinsky, who's from our RhoMobile software team. He's been with RhoMobile for several years and is one of the engineers that has worked on this API. So welcome, Alexei.
Hello, everybody.
Okay. So great. So we're going to go over the intent API. We're going to then explore how to use it and really kind of talk about and show you how to send intents and receive intents, and then share with you some resources to help you get going and using this new feature. All right, so let's talk about intents in general. So um, this feature and the name really kind of comes from, if you're familiar with Android development, you this the word intent probably means a lot to you. But for those who you are not familiar with the concept of intents, it's really about having two applications be able to communicate with each other. There's many different scenarios where you may want to communicate from your RhoMobile application to, let's say, a native application on a device, or even another RhoMobile application. You may want to share some data. You may want to execute some functionality. You may even want to communicate with a service, right? So it doesn't necessarily need to be an application that has a UI, but it could even be a service that's running in the background. In this kind of simple example here of two applications, one is look at the screen there. It's kind of like a restaurant application. So let's say your application, your RhoMobile application, is a restaurant application, and you wrote the code to do that, but you wanted to be able to expose sending a text message, right? Let's say you wanted your customers to send you a text message. You don't want to have to write the whole SMS part of the application, and you want to rely on the device or the platform to provide that functionality to you. Well, you can simply launch an intent that an SMS application, a text messaging application, would then take over and allow the user to send and receive intents, send and receive text messages, and then return back to your application. So with intents, there's two sides that are involved here: the sender and the receiver, and we'll get into those concepts. So before we talk about the RhoMobile implementation, let's just talk a little bit about what's happening under the covers. This interpretation of this API is kind of a blend across all the different platforms that it's supported on. Firstly, it's primarily based off of Android intent. So if you look at the Android developer documentation, you'll see a pretty comprehensive set of capabilities for cross-platform application inside of Android. Okay. And it's pretty extensive. In fact, it's not only used for cross platform between two applications, it's also used within a single application to basically share information between screens or activities. So our API is really heavily skewed towards the Android side in terms of its capabilities that we expose through our abstraction layer through the methods and properties. Um, on iOS, there's a concept called URL schemes that's been around for a while, and Android supports URL schemes as well. But iOS supports URL schemes, and really, it's about it's used in many different ways. But a lot of the typical use cases is from a website, somebody's on Safari and they click on a link that launches into the telephone dialer or the SMS application, or your application could even create a custom URL scheme. So There is some capabilities for passing some information, launching custom applications to do the same types of things that Android exposes, but it's not as robust in terms of capabilities. So when we're doing this on iOS, it's you need to kind of think about the URL scheme approach to communicating. On Windows Mobile, it's we're really utilizing named events, right? So if you're familiar with Windows Mobile, you may know about how to create a named event and be able to communicate across applications that way. And our Intent API under the covers for Windows Mobile is using that same type of concept. So when you look at our API, we'll explore all the different options. uh, think about how this is happening under the covers, because chances are you may be communicating between a RhoMobile and a native application, and you may want to look at some of the ways that are available to you and get familiar with what's happening under the covers. Why did we develop this API? Well, for a couple of reasons. For the most part, we're, as you know, heavily driven by our customer requests. And we've heard this request from several of our customers to simply just launch an Android intent. They had an application that they didn't have control over in terms of changing the code or possibly porting it over to Rho at the time, and they really wanted an easy way to communicate. And this is what really kind of started this our implementation of it. And then also, likewise, we're also producing a lot of Android devices. And internally, we have some software that's also residing on that exposes intent. So naturally, it makes sense for RhoMobile to also provide this functionality. So we took that basic concept of just sending intents to really make it cross-platform beyond Android, and to also allow sending and receiving of intents. Okay, so we're very interested to see if this API is meeting all of your needs, and of course, if there are things that you wanted it to do that it's not doing, please let us know, and we'll look to get that into future releases. So how do you use this API? Let's talk a little bit about um, how to use this API and what you need to do to get going. This API is documented on docs.rhomobile.com. And there's a couple things I want to point out with the API. First of all, this API is in the roads part of the roads repo, or the roads open source part of the code. So you can go up to GitHub and look at the roads project, and you'll be able to see how this API has been implemented. It is being implemented as what we've been calling a common API. So as of version 4.0, we're really exposing all of our APIs going forward as this common API approach. Common meaning, we are defining it via an XML scheme. So this standard scheme that we developed, and we basically provide the same experience whether you're using it on JavaScript or whether you're using it on Ruby. Okay. As being part of the Roads repo, it is open source and openly available to use. The one little asterisk there that I want to point out, which comes up when in terms of licensing, is running on Windows Mobile or Windows CE. All of our APIs on Windows Mobile and CE do require a Rho Elements license, and that does not mean you cannot use this API. It is fully functional even if you don't have a license. Um, it's part of our core API package, so there's no special extension or settings you need to provide in the build.yaml in order for it to be available. Some of our other APIs are built as an extension, and you need to actually add extension capabilities to build.yaml in order to get those capabilities. This is not. This is part of the core package, so it's openly available for you to use. So I'm just going to pause for a second, just kind of jump over to the question area. Okay, I don't see any questions. So, all right. So let's go. Let's explore sending basics. All right. So now we talked about the API and some, kind of the concept. Remember, we talked about there's two pieces of intents. There's the application that's sending an intent. There's the application that's receiving an intent. And there's really kind of three things, sometimes two, but really three things that you need to be concerned about. Um, The first one I want to talk about is I'm calling a signature. You see these fingerprint icons on the slide. What this means is really that you have applications listening for a particular um, signature, right, or a particular set of settings. Um, Listening for intents. And in order for your application to be able to send it properly to the receiver, you need to know the kind of frequency or fingerprint that they're listening on. Okay, and this heavily applies to Android because there's a lot of different combinations of signatures that are available. So if you don't have the kind of handshake there going in terms of what I should send and what the receiver is expecting, then the intents will not work. So you need to understand what's happening on both sides of the coin. The other piece that is important is of um, the type of intent, and we'll explore some of these in our examples as we get to it. And for the most part, this is again, like I said, heavily focused on Android, so some of these concepts don't necessarily apply. So like starting an activity or a service, or even just the type itself, may not necessarily apply to Windows Mobile and iOS, but on Android it does. And I think that's where most of the people are going to be using this API. So throughout the presentation, you may see me reference Android only types of features, and this is one of them. So type, there's different types of intents where you can just broadcast it out to particular applications that are subscribed to receiving broadcast intents. And then there's activity intents where you actually want to um, launch an application, expose a UI, and do something. It may or may not return some information back to your application. For example, maybe in our documentation examples, we show how to plot a point on a map. So maybe you're using our geolocation APIs, and now you want to just show an address on a map. Well, you don't have to write that code. You can launch an intent, and it'll just show the map, right? Or in the case of sending a text message, that's an activity where you're actually launching UI. And the other type of intent is about service. So you want to talk to a service that's running in the background that really has no UI around it. So type is important, particularly on Android. The signature we talked about will show some more details. And then typically you want to package up some data, right? You want to append, let's say in the example of the SMS message or text message, you want to actually append the body. Maybe you want to have pre-can the body of the text message. So that would be an example of some data objects that you want to include in your sending. So your row application needs to be aware of the applications that are receiving it, and the different fingerprints or signatures that they're expecting. And these are the types of information that you need to include in your package of sending an intent. So that's kind of the concept in general. Let's look at the API in more detail. Um, well, actually, the one thing I wanted to point about the APIs I forgot to mention before is you can see from this API there's only three methods. So there's a send method, there's a start listening, and a stop listening, and that's the API. Although it seems limited, maybe at first glance, it is actually quite powerful, as we'll see as we go through the examples. So we're going to first look at this send API, and let's take a look at some of these parameters. And this is on the documentation site, but I wanted to go over the parameters in more detail so it's clear. In this diagram here, you see, and you'll see throughout the slide deck too, that I've highlighted things in the Android green if they're kind of Android only types of content. So although we have all these parameters available when you want to send an intent, um, they may not necessarily all be used, and we'll show some of those examples in a minute. Intent type is one parameter that's Android only concept. And I talked about these before, the differences in broadcast activities and service. This is highly used in a lot of the Android intents, the standard intents that are built into the platform, but also typically in applications that have set up their own intent filters will be using this as well. And we'll explore some of the differences in broadcasts and activities a little bit further along when we talk about RhoMobile applications receiving intents. Action is a string that's essentially telling the Android system the type of action um, that you're requiring. And some intents have actions, a lot of them do, and some of them don't. You'll see in our API this value is a string, and in some of the examples you may see the string actually represented as an Android constant. So when you actually are looking through the examples, you may see, like in this case, I'm using the string representation of, action send constant. And under the covers, we're actually trying to figure out or testing that this is an Android constant first. So you can actually reference them both via Android constant names and the actual string representation. However, this actually needs to be a string. So don't put the constant in here. You can put the constant in here as a string representation, but not the actual constant. Categories is again something that some intents use and some intents do not. And this is an Android concept. And in the documentation, we link out to the specific Android documentation where you can take a look at these categories. So Android has a bunch of categories defined. And again, these are all things that applications could choose to build that signature, right? That fingerprint of I want to listen on certain category types, certain actions, and then that's how my application knows to handle this intent. So categories in our API is an array list of categories. So in some cases, you may have to list more than one category in order for the intent to be triggered. And this is how we expose that. App name is another parameter property. And this obviously this parameter is an object or a hash in Ruby. App name is kind of have different meanings for the different platforms. In iOS, you would put your bundle URL scheme, and this is something that you see in your iOS application configuration. Typically, it's the package name com.yourcompany.your app name. In Android, you can also specify the app package name as well. And in Windows Mobile, this would be the actual application name, not with the exe. Sorry about that. Target class is something specific for Android. So you may, in fact, you may have a custom Android application that you will want to launch to a particular activity or a view, and you want to specify it by app name and class or activity, right? So that's just an option for you to launch the intent that way. URI is about URI schemes or URL schemes. There's some standard ones that are available on Android and also iOS, like SMS, telephone, mail to, and in a lot of cases, those intents you can pretty much just get away with just providing the URI, and that's it. Like if I just launched an intent with this particular example, it would launch the SMS application and provide this number to it, and that's all you really need to do. So we provide URI as an option, and this is available on multiple platforms. And then one of the next parameters that we have is MIME types. So these are standard MIME types represented as strings. So you'll see in an example that Alexi is going to do about opening PDFs and how he um, expose or set the MIME type to the correct MIME type for the application. Permission is an option you have that's not highly used. I really haven't seen a lot of intents. This is Android only again that use permissions, and a lot of times they're associated with URI. So some URIs you may have to specify a permission like a read or create permission. So again, this is related to however the intent receiver has been set up. These are the things you need to specify. Data is an object that we use across the different platforms um, to provide a data set, right? And this is represented as a hash here or an object. So if you want to provide multiple properties or multiple properties in your data elements. I only have one here. Actually, I have two. I have body and subject listed. You would provide a hash of name and value Okay, and in the Android world, this is very similar to what Android calls as setting extras. So when you see Android referencing, in their examples, they say set extra, and they have some Android constant. You would essentially put the Android extra constant name here, and then the value there, and that's how you would send extras on Android. So extras is an Android concept. And that's the send API. We'll talk about the callback handler in a minute. That's the second parameter in this method, and we'll go over that in a bit. So here's some very simple examples across the different platforms. If I'm doing this, and this slide is really talking about if I'm trying to send to, let's say, a native application running on Android, a typical set of parameters. You'll see across these that there's different elements of the parameter object being set and defined. So in the first example, typically Android is a combination of, like I said, action and other things. So in this example, I'm forcing the SMS or text messaging application to appear, and I'm including the phone number in the URI as a typical standard URI scheme for SMS, and then I'm also including an extra SMS body and putting in my text that will be appended to that text message. That's an example of a send parameters in the Rho API. In iOS world, I am essentially just setting the app name, the URI, which is the URL identifier in the iOS settings. This is the example of the application name, and then the data that's going to be included. And how this basically gets interpreted is this URI string, which gets created from the application name. So here's the URL scheme, and then we provide the URI as values or variables, as well as the data, all URL encoded. So in your iOS application, you're going to see these extra parameters available to you when this URL scheme is triggered. And then in the Windows Mobile world, we're basically just essentially providing the app name along with the data, and then under the covers, we're doing the named event based on this information. If at all you're ever curious to see how we're actually doing this under the covers, you could, like I said, look at the source code in the Rhodes repository, and see what's going on there. So I am going to pause for a few minutes to see if anybody has any questions, and then I'm going to hand the baton over to Alexi for some demonstrations. All right. I don't see any questions. All right. So Alexi, I am going to hand it over to you. Make you presenter.
Okay.
Okay. Sorry, it was taking a while to switch there. And if you can
Okay.
just share your screen. All right. So I
Uh,
see your
do
screen. Just before,
everybody see my
Alexi,
screen?
Alexi, just before you get started, I'm sorry. If you can just talk a little bit louder. You got a little low on me there. And then just a second, I just had a question that came in from Gerban, sorry. Will you mostly be defining different parameters for different platforms? It's not so much, yeah, there's definitely a difference in parameters for the platforms. We have some very specific Android parameters that you most likely need to provide. Um, and for iOS and Windows Mobile, it's think about how it's being done on those platforms. On iOS, everything's a URL scheme. On Windows Mobile, it's a named event. So whatever the native platform provides, that's what we essentially need to provide. We'll in iOS and Windows Mobile, will automatically append the data element, right, to the object. And in a lot of cases, we'll look at if a an app name is provided, we'll try that first, essentially, and then if a URI scheme is provided, then we'll try that as well. So When you get into Android and you're looking at sending intents on Android, it usually is a combination of different parameters based on what the receiver is set up to handle. So if you just look at some of the simple common intents that Android has built into the platform, you'll see this, and we link to it in the resources slide. You'll see some different examples that show, in this case, I need to provide an action and a MIME type, and in another case, I just need to provide a URI. So it all depends on what the receiver is set up to handle. Okay, so I hope that answered that question. All right, Alexi, why don't you go ahead and go through your examples here?
Um, Hi everybody, one more time. First of all, I want to describe uh, the environment which will show you the intent capability. We will run several types of intents. First of all, some common types like uh, what intent was designed in Android for. It is like, I want send a mail. I don't know how and who will do it, but I won't send it. Uh, Second one, I want to view this content. I don't know who will view it, how it will be viewed, but I want to view it. And then we will go to more specific cases like building communication between uh, two applications. One first application is routes application, and another one is native Android application. Um, I made some preparation and want to pay attention. I will run all examples on Android emulator, but and I installed previously PDF Adobe Reader on this emulator because this is needed to view PDF documents, and also it has mail client installed and set up. On most devices, real devices, you already will have some PDF reader or, and mail client. But for emulator, you need to do some preparation. Also, to routes project, I already added PDF document. Just view it. Some example document. It is placed aside of uh, other assets like main startup page index HTML. It is much easier to place it in the same folder as this index document. So let's start. First of all, we will got example of sending email. It's just simple and clever. I just call raw intent send. See, add uh, intent type start activity. It is constant defined in raw intent object, raw intent class. Sorry. I want to send mail, so I'm using a common constant name from intent class, Android class. It is handy to use these names. Do not translate it into raw strings. You can look on Android documentation in intent class and can use all these constants as values when you specifying action category or some extra keys like extra email, extra CC, extra subject, and so on. All of it can be found in documentation page. Oops. Sorry.
So the key to point out with that, Alexi, if you just jump back to your code for a second, is to use those constants in string format in the Rho API, and we interpret it correctly.
Yeah, you can see
Okay.
that, for example, extra CC can be found in Android documentation. This is developer Android.com.reference. Um, so we specified action from according to the Android documentation. We specified the form of body of our mail, the format. This is just plain text, and we specified addresses and other data in data item. And as you can see, according to uh, Android specification for mail client, addresses should be passed as arrays. So it is important and also demonstrates the flexibility of Internet API. So you can build some complex data structure and it will be correctly translated into Android Internet. So um, that's all for first example, and we try to run it. Just some time. While building, we'll look forward. Um, at emulator. I will show you some third-party native program that I wrote to communicate with this sample application. Um,
Yeah. So what? Oh, there we go. Okay. So it looks like it's going. So Ah, okay. So while that's building, Alexi, just wanted to mention the intents on Android. Sometimes when you may have seen it in an application that you use in your personal device. You want to share something, so there's a share button on an application, and then you see a list of applications that come up. So you see this application chooser. What's happening there is an intent is being launched, and the system has multiple applications registering for an intent. So although you're sending them, you may not know and you may not care what application handles that. So that's where I was talking about before, where you actually understand the receiver side or the fingerprint side, what's going on here. When you're in control of both sides, you can really have some nice cross communication going on by defining a more strict signature or fingerprint on the receiving side.
yes, this is just to show that it is very simple application that has three buttons and it is set up in on startup of application, which is set up to first return result of uh, started application when you want to call something like I want to make a camera shoot and want to get result back. And camera uses uh, the same methods set result to set result back and send intent directly to calling application. And another button to send broadcast, uh, just send broadcast according to filter setup in intent. Uh, and another is just start back our application exact by its name. We will just use this application to communicate with ROTS application and to send data from ROTS application to this application and back, make some data flow
Yeah, and we'll
both
get into
ways.
more of that as well in a minute. So I think the build should almost be ready. While that's going, So yeah, Alexi was just kind of showing you how it normally is done in the Android native code, so you can kind of get a reference for how it relates. But Alex asked a good question about why are we using the emulator instead of Row Simulator? Well, the intents, and Alexi, correct me if I'm wrong, but intents are not supported on Row Simulator, and it really requires that native platform from running. Remember, I mentioned before under the covers, it's doing things using the native scheme for cross-platform application communication. So that's why we require the emulator or a device in this case
Yes,
as well.
I want to pay attention that um, the simulator is just simulates the runtime for ROTS application. It's it is not really emulates device environment and so on, and it doesn't emulate native part of ROTS for Android, iOS. I don't know. So to use intent functionality and show how it works on Android, we need to use real device or Android emulator, which is really a virtual Android machine, which is run on post PC. First time it take long to build.
Yeah. So, Alexi, why don't we, while that's still building, why don't we show the open PDF code, and then we could jump back to the application.
Okay, Open PDF is quite simple as well, but has some secret because you need to pass correct URI uh, to internal document. If you have document on SD card, it is no problem. You can just put file URL like file SD card PDF, and it will work
Yeah,
outside
SD
SD
card,
card.
not DS card. Yeah.
Yes, SD card. But if you want to show some internal document which is packaged into APK file in assets, then you need to use RODS facility to export the content with content provider. And in this case, the URI will be started with content scheme, uh, then application package name, and then path inside package, which starts with raw data and then common path to the file. This is quite magic, but really you can look on this URI, I think, with JavaScript facilities, looking what current URI is loaded.
Yeah, so this is the standard way to share documents across applications, right? With this content URI in Android. So, all right, it looks like it's
Okay, it
just,
looks it has started,
yeah.
and we can see what will happen if we press first link. If we will go this link, which will call send mail. Um, it will ask us, wow, what program we want to use, because we just specified action as send, action send. So Android doesn't know what client really we want to use. This is the philosophy of intents. So we want to use email because we specified email addresses, and it will open mail client and will fill it with uh, fields we specified. all these mails to uh, two emails in two fields, one CC, subject, and content. That's simple. Then you can press send, and mail will go on the wall. Really, you can look on Android documentation, and you can silently send email uh, with special action, but you will need to specify some permissions in Android manifest. But that is Android specific stuff. You can look it in Android documentation. Okay, now go back from mail program.
So
Um,
Alexi, just what I would suggest, maybe we just spend time instead of just doing little code and then building for each of these examples. Let's talk about the code, and then if we can do one final build, or if you have that application already on there. Just because we're probably going to end up running out of time if we keep going this way. You know what I mean?
Next build should go much faster, several seconds.
Okay.
That's just because just first build. So now we will test opening internal packaging. You can see in project 3 that this PDF uh, is near my index document. Console, so already go through all native code and compile in Java and package it. Okay, okay, started. Starts the application. Just a moment. Yes, and starting our application. Okay, I'm touching second link. It's open PDF, and it opens uh, common application. Just because it's just only single program that can view PDF documents, it doesn't ask me a question what program to use. So you can see that it's very simple. Now we will go with starting with explicitly starting activity which we want our native application I wrote specially for this test. Let's start running and we'll discuss what we do in this case. I as well in first as in first example I call start activity intent, and now I'm assigning another common action main. Usually this action used to launch application from Android launcher. I'm specifying exact package name. Since action is specified, I do not need to specify target class because you can use intent filters defined in Android manifest. And I pass some data which application should get and display. In application, uh, when we get this, we will just look that application is started. It's quite simple. Also, we can press a return button and see if we can get callback parameter. We can get callback from this application and get data from application back. You can see that I will try to show some pop-up with message get from parameters which goes from intent, which we send back. Okay.
So the function intent parameters is the callback handler for the send. What we're doing here is showing that callback handler for the send, right? And then the intent params is the callback object, which you'll have available to you, data object and other ones, right? So that's what we're demonstrating here is how to handle the callback, or if you want to launch an intent with some sort of information back from the other application. Okay.
Yeah. Okay. So I'm clicking on third link, and it will open as a native application. Yes, this is our application, and uh, I can press return result, which will call uh, set result in native application, and will finish the activity. Yeah, and we got uh, to this callback function, and it called show pop-up with the text that I passed to the application in initial intent. So, for example, I can change it. Test message 2 and run it again, and it
Alexi,
will
can you just flip over
display.
to your Android code where you're actually doing the return result button so we can see how that is being sent back? Okay.
It is just set click listener for this button, and it calls set result. It get initial intent which was used to start the application, um,
Okay.
and
So
then call finish.
the key there is the set result method and finish, and that's how it
Yes.
comes
Also,
back.
I think it is better to kill initial application. Just a moment, because in another case we can get wrong intent by uh, get intent.
Yeah, the target app, right? That's what you want to kill.
Yes, pause stop. Okay. So go back to our application. Go open native activity. It is started and return result. Test message 2.
Okay.
So we organized some data flow to application and return the same data back. Okay, so now we will try to send broadcast uh, to the same application, but uh, it will not start our application because broadcast doesn't call start activity. Um, Send broadcast. So we will need to switch to the application manually, but we can show, we can look at application at Android log and see that it will be printed. Okay, we insert the code. This, as usual, raw intent send. Intent type now is raw intent broadcast. Action is our custom uh, string that we use it in intent filter is in native application. App name is, as in previous case, same from RhoMobile target app, and some custom data as well. In our application, we can look at Android manifest. We have broadcast receiver, which handles this action, RhoMobile target app broadcast. Um, and we have um, broadcast receiver that will uh, receive our broadcast, log it into log, and then it will call automatically another action back, and we will receive this uh, into our roads application. But it will be in second step. Okay, I will look as usual on my console.
So the starting an activity
Just
and
to
doing a
show.
broadcast is very similar in nature. It just depends on what your application is set up to handle. A lot of times the broadcast intents are or for system type messages like the battery's low or Wi-Fi signal lost, right? But you can also leverage it. So it depends on your use case and how you want to configure this. So we provide both of these options. They're kind of very similar. So look at the Android documentation to understand the differences. But again, it all kind of depends on
Yes,
how you
but
have that.
difference.
Go ahead, Lexi.
Sorry, the difference between broadcast and start activity is that start activity is usually delivered only to single application, and broadcast can be received by a number of receivers. And also, start activity is always start some user interface of another application, but broadcast can be handled in background. So you will not see any changes on screen. It just sends data and application may proceed it in background. So our application is restarted and we can send broadcast. You can look on the log below. Oops. And our target application is reported that it received the broadcast. Now uh, we can set up listening for back broadcast and set up broadcast receiver for our routes application. This is uh, some advanced step because we need to first um, use some embedded receiver to routes application. It is uh, just manually add to Android manifest template some uh, definition of this receiver, and it should be exactly as I typed.
So I just want to point out here this example code that Alexei has created, this project intent example. In version 4.1, when you generate an application using the application generator, it automatically generates this Android manifest.erb file that you see in the root of the project, and automatically sets this up. So this is kind of new, although we had ability to customize Android manifest in the past. It's even easier now, right? So if you look at the build.yaml, you see this new option called, maybe it's not a new option, but
Yes,
manifest template. It's what's new is it's automatically created for you and links to this file. Older projects, you could add this file and put it anywhere and make sure you reference it properly here in the build.yaml. So this is used in your application when it's being built, and we can even show Alexi the end result after it's built, and kind of talk about some of the filters that are already there. So what
yes,
you've done is yeah.
we will not discuss overall stuff of this template, but really you can rewrite any part of this manifest of this template if you need some special functionality and some special cases covered by manifest. In our case, we just need to add receiver tags and fill intent filter, which we will use to get data back to filter our broadcast messages. it is some using of generator variable which will substitute here our category with name of package. Excuse me. Sorry, 1 second, please. Excuse me, I'm back.
Okay.
So we will create this receiver and we'll use it to get data back. So let's start with it. Um, let's examine. Yes, we already. Yes, we need to fill also uh, our listen for intent function just to start listening the uh, intents. This listen for intent method will start listening for any intent you receive in your application, even if some another third party will call you with from launcher, for example, you receive this intent into this callback, or even if to road service some I don't know activity will connect, you also get notification in this callback. So you need usually do some check what real data is received. Are you wait for this data or some another party send you some information?
So Alexi, while you're building
So
that, I'm sorry to interrupt you, but I see we're getting close to the top of the hour, and some people may have to leave. We're going to still carry on because we probably have another 10 minutes or so. So if you do have a question, please ask it in the GoToMeeting, and we'll answer it. And you can watch the recording back for your answer. Um, so if you want to start queuing up the questions, that would be great. If you have to leave, we understand. But for those of you who can stick around for another 10 minutes, we'll probably be done shortly after the top of the hour.
yes, really, it is last example. It's most complex because we send two broadcasts two ways. Um, so start our application.
So in a lot
Uh,
of the use cases, you'll probably end up just doing the sending part, which we've showed you some examples. This part is where you actually want your row application to receive intents or to listen for them and do something. So all right, so there we go. It looks like it's launching.
so currently, if you remember last time we sent broadcast and it just received by uh, another application. And now we can call start listening to start listen for our broadcast. And when we send broadcast one more time, we got response with the text which we send to this application, and then it call us back. Yeah, this is test broadcast message in data. That's voila, it works in all ways. And we discussed how to call some common actions like sending mail, like opening internal document. We're discussing how to open some third-party activity and organize data flow to application and back. And finally, we discuss it and look at how to send broadcast that data to many applications and how to get broadcast back.
Yes, and we're
Um,
going to provide these code examples. So Alexi, I just took control of the screen to get through the rest of the slides here. Okay. Um, Yeah, so
okay, yeah,
thanks Alexi for showing those examples. At the end of the slide deck, there's a list of resources that I'll get to in a minute. But just to kind of summarize the intents, because a couple of questions came in about what we need to do on different platforms. What we described for what Alexi showed was actually something for Android, right? Android mechanism under the covers is to have these intent filters or broadcast receivers. So for Android, you need to in most cases, provide this code in the manifest file to set up the receiving properly. If you're communicating between row applications, you're pretty much just using the APIs that we just went over. And there's really nothing special you need to do across the different platforms except when it comes to Android, right? So this one piece here for receiving intents is to essentially define the intent filter or receiver if you need to specify a custom, filter for the particular response for receiving. And then otherwise for receiving, you're just essentially listening for that, enabling the listening for receiving intents and handling the callback. So this is just kind of a repeat of what we just went over, but this is um, this is the new piece in 4.1 where we have this common receiver. So you're always going to put in the case of receiving a broadcast type of intent on Android only, you're going to update the manifest ERB file and add this snippet of code here. This will always be com.row.intent.intent receiver, but inside of here, intent filter is where you're going to put your standard Android intents if you to define the intent filter that you want to enable on Android. Okay, so again, this is Android only. Um, what Alexi alluded to before was that we have some standard intents already in the application. So if you built the application in the bin folder under Android, you can see what the end result is for the Android manifest. And you'll see these intent filters that we automatically put in there. So, we set up for handling battery events and Wi-Fi events. These are kind of standard. So when you do that start listening, these intents will also trickle down to your start listening callback handler. So you need to be aware of that. And if you wanted to receive an intent on Android um, via the activity mechanism instead of broadcast, you would add your own intent filter there and set up the appropriate signature or fingerprint. Okay. Um, Alexi went through the demo. I had an advanced demo, but we're running out of time to go through. It's in the code resource where essentially I set up an application, a row application, to be a barcode intent. And on Android, I triggered that. I sent a broadcast intent to this handler, and it would essentially turn on the barcode in the row application. And when the barcode was scanned, it would return back the barcode data to my Android application. So from a native Android application, I can get that native, barcode scanning or any other API that Row provides. So this was more of an advanced example. The code is up there if you want to take a look at it. List of resources available to you guys. So the intent APIs is up on Docs. We have a guide that walks through kind of some use cases on sending, receiving, the different combinations of things. Here's a link to the Android intent guide. From the Android intent guide, you can get to the API classes that Alexi showed. The sample project for this code, the project that I mentioned, as well as the code that Alexi was sharing, has been put up on the RhoSamples GitHub project under this 4.1 intent test app folder. Okay, and then another good resource that not everybody knows about, but is available for open to view, is our testing specs. So this is what we use to actually test a lot of the different API combinations, and we use a Jasmine test framework. But in there, if you look through the code, you can actually see some different things that we're doing, and it's a good learning tool as you're going through the APIs, you can leverage some of the code in there as a learning tool. If anybody has any other questions, please enter them into the question area. What's coming up is our printing API demo, just kind of like what we did today. We'll walk through the printing API in greater detail. That's a new feature. And the following week after that, we'll cover DPX, which is a new capability in 4.1 as well. It's currently in a beta status, but we'll go over that as well over the next couple of weeks, so you have a good overview of the new capabilities in 4.1. So that's all we have prepared to present today. I hope you found it useful. If anybody has any questions, please let me know. I hope I answered the other question. It looks like it was removed, but somebody had a question about, do we need to, if we have multiple row applications, do we need to set up things differently on each platform? And the answer is really no. The only thing you need to do special is, like I said before, on Android, is to set up the manifest file properly. Okay, any other questions, guys? Okay, Alexi, do you have anything else to end with? No, Alexi?
No,
Okay,
I'm complete.
all right. Okay, well, I don't see any other questions. I appreciate everybody's time today. We will see you next time. Thank you.